Hi ladies and gentlemen, this is the video that goes with section 5.2 on arc length. Before we start, we're just going to discuss some portions of circles. Now from GCSE, you've got three diagrams there. You should know that the first diagram shows you an arc, and an arc of course is a fraction of the circumference. The second diagram shows a sector, and that is a fraction of the area of a circle. And the third one is a segment. And a segment is just a sector with a triangle cut out of it. So we're going to have a little look at arc length. Now we said that using radians can make our calculations a lot easier. So I'm going to demonstrate that with this arc length. Now you can see on the diagram, the arc length here, shown in red, I'm just drawing it in red, is a fraction of the circumference. So first of all, we're working degrees. So arc length we usually call S. So if I wanted to work out the length of the arc, so S equals, well, the fraction is theta over 360. Remember I said I'm working in degrees. And it's a fraction of the circumference, and the circumference is 2 pi r. Now, there are very little there that cancels out. The 2 and the 360 will cancel out, giving me a formula, theta pi r over 180. So that's a formula that would work in degrees, but it isn't very nice. It's not that bad. But I want you to see what happens if we work in radians. We're going to do the same thing. So S equals theta over, now a full circle would be 2 pi, so that's the equivalent of 360 in degrees, and then you've got 2 pi r, which is your circumference, and if you have a little look, the 2 pi's both cancel, leaving you a formula S equals theta times r, or we often write it as r theta. Now that's really important, that one. That is a keeper. You must learn that one, and that is the formula, but it only works in radians. So r theta, quite useful formula to find the arc length if you are in radians. So we're going to use that now in a couple of questions. So the first question, it says find the arc length of each sector. So we need to find S. So I'll put S on it. So S equals r theta. S equals 7.2 times pi over 4, and therefore that equals 9 pi over 5 centimetres, and that's exact. You can write it to 3 significant figures. Next question, we're asked to find the arc length, and you can see this is quite a large arc length. I'm marking it in red. It's often referred to as the major arc because we have a major sector. So we actually need this angle here. I'm going to call that theta. Okay, so you can see that theta in our case is 2 pi, because that's a full circle, minus the 1.8. So if S equals r theta, S equals 6 times 2 pi minus 1.8, S equals 12 pi minus 10.8, and that is exact. That's centimetres, or you can have it in to 3 significant figures, and that's 26.9 centimetres, and that's correct, 3 significant figures, which is one of our standards. Sometimes you're asked to rearrange the formula. So you can see on this question it says find the radius of the sector. We're not trying to find the arc length, we're given the arc length. So if S equals r theta, then r must be S divided by theta, and therefore you can stop the video, fill that one out yourselves, and check with the model solutions. The third question, as well as using r theta, we're going to use the cosine rule. The first thing I'm going to do, because it's an exam question, I'm going to use my highlighter. It says ADC is a straight line. Quite important piece of information, that. ABD is a sector of radius 4.8 and it has an angle of 2.5 radians. Clue there, radians, make sure calculator's right, working in the right angle measure. We're also told that AD equals BD equals CD. And what are we asked to do? We're asked to find the perimeter of the whole shape. So we're going to do it in bits. The first thing I'm going to do is I'm going to work out AB. AB, our theta, R is 4.8 times 2.5. So that's 12 centimetres. We now need to find BC. So let's go back and have a look at the question. It tells me that the length CD is the same as AD. So this is 4.8 centimetres and DB is also 4.8 centimetres. And it would be nice if I knew this angle. I'm not going to call it theta because we've already had a theta. I'll call that one alpha. So you can see that alpha equals, well, it's pi because that's equivalent to 180. It's on a straight line, minus 2.5. I'm not going to work that out. I'm going to use my calculator to do that. Now, you can see that triangle BCD is an isosceles. We've got the two sides and the included angle. That means we're going to use the cosine rule. So I want to find BC and I'm going to use the cosine rule. Just pop it in here. Idea. Now I'm not going to write down the cosine rule, you all know it. So BC equals square root 4.8 squared plus 4.8 squared minus 2 lots of 4.8 times 4.8 times the cos of the angle. So that's theta, pi minus 2.5. Okay, pop that in your calculator and you get 3.027. Doing that to 4 significant figures because I want my final answer correct to 3 significant figures. So the perimeter is, well, it's 2 lots of 4.8, which is the length AC, plus AB, which is the 12, plus the answer I've just found. Okay, and if you add those together, you get 24.6 centimetres, and that is correct to 3 significant figures. And that is the end of section 5.2.